session, we are going to see the types of 3D printers and materials. And in this session, you'll learn about like different types of 3D printers and the materials used in it. I hope this session will be helpful to you. And the important tip is that this session is going to be like completely like informative. So like pay attention and have some interest so that you can learn more from this. Okay, like as an intro, like I am Dishant and I'm studying metallurgy in IIT Madras, and my co-organizer is Karthi, and he will introduce him now.
Hello everyone, I'm Karthik from Metallurgy and Material Science Department, currently pursuing second year. Next slide. Okay, let's move on to the topics. In this session, we'll be covering material type, size, and material used, other types of 3D printing. Under the material type, we'll be seeing 3D printers based on filament, resin, and powder. Under size, we'll be seeing desktop and industrial types of 3D printers. These five we'll be seeing like overlay, what are the definitions and all. But under material used, we'll be seeing polymer, metal, and ceramics. These are very like we'll be using everywhere. So we'll be seeing these 3D printers briefly. And there are some other 3D printers which doesn't come under these types, will be covered under the other types of 3D printers. And next slide. Based on material type. 3D printers can be classified based on the material type in the printing process. The most common types are filament-based, resin-based, and powder-based. Filament-based 3D printing. Technology we use here is FDM and FFF. The full form is given. And the process is thermoplastic filament is heated and extruded through a nozzle onto a build platform layer by layer. When it is extruded, it comes out in a molten state, and when it's laid on, it will get solidified, and through which we'll get a 3D model. We have pros and cons. The pros is that it is relatively expensive when compared to other 3D printing technologies, and it is widely accessible. Good for prototyping and functional parts. Cons is that it has a lower resolution when compared to resin-based 3D printing. It has lower resolution, and the precision is not good when compared to the other technologies. The layers are visible and limited material options, like filament material used here are very less when compared to other technologies. We are constrained to use only 2 or 3 kinds of materials. Resin-based 3D printing. Technology we use here are SLA and DLP. There is stereolithography and digital light processing. Process is that it uses liquid photopolymer resin cured by UV light to create layers. Like UV light used here is high intensity UV light, which instantly cure or dry the resin. And pros is that high precision model is made. The surface is very smooth, and it is used to produce intricate designs. Cons is that resins can be expensive. Yeah, it is very expensive, so it is not much like very affordable. It is not affordable, and requires post processing such as UV curing, cleaning in isopropyl alcohol. So it's a very big work to do with it. We use isopropyl alcohol in order to clean the uncured resin, leftover resins, yeah, and smaller build volumes compared to the FDM. And next, powder-based 3D printing. Technology we use here is SLS and MJF. selective laser sintering or multi-jet fusion. Process is that we use powder bed fusion and the technology like SLS or MJF is used to fuse or bind the powder together layer by layer. Pros is that it produces complex geometries, supports various materials, includes metal, ceramics, and plastics. Cons is that it is also expensive, like resin-based 3D printing, requires specialized handling of powder materials. It also has some post-processing works to do. Can we move on to the next level? Okay, the next one, based on size. Like, desktop 3D printers and industrial 3D printers. Like the name says, desktop is small size and industrial for big size 3D printers. This desktop 3D printers, the size is compact and suitable for use on a desk or tabletop. It is easily portable. And the technology we use here is FDM, FFF, using the thermoplastic filaments. Applications are like it is for personal use, I say. We can't use for industrial or of making a final product for making prototypes or for self educations for educating students and for some hobby purpose we can use desktop 3D printers. It is affordable also. And the features we use are features. It is generally lower cost, easy to operate, easy to use, and accessible for personal or small business use. Examples are MakerBot, Ultimaker, etc. Industrial 3D printers. The size is very large and moreover, typically not suitable for desktop use. Technologies we use are SLS, SLA, DLP. The applications are like used in manufacturing, aerospace, automotive, healthcare, and other industries for producing functional prototypes and end-use parts and tooling. Features: high accuracy and resolution, support for a very wide range of materials, including metals, ceramics, and composites. Example: EOS, 3D systems, HP Multijet Fusion, Formlabs for SLA or DLP. Can we move on to the next slide? So based on the material used, as I said before, we'll be seeing briefly about these topics in the upcoming slides. Um, the 3D printing technology can be categorized into polymer, metal, and ceramic-based 3D printing. First, polymer-based 3D printing. The material we use here as PLA, ABS, PETG. The full form is given. That is polylactic acid, acrylonitrile, butadiene, styrene, polyethylene, terephthalate, glycol, and nylon, etc. Properties are it is very lightweight, flexible, and cost. It is very cheap as well. And then applications for making a prototype, consumer goods, medical instrumentations, and fashion and automotive parts. For manufacturing these things, polymer-based 3D printers are used. And we move on to the next slide. Hello.
Yes, sir.
And I forgot to say polymer-based 3D printing. There are three printers, especially FDM, SLS, and SLA. So note those points. Metal-based 3D printing. Materials we use are stainless steel, titanium, aluminum, cobalt, chrome, alloys, and inconel. Hello? Okay. Uh, stainless steel, titanium, aluminum, cobalt, chrome alloys are like CO28, CR6, MO. is mainly used for aerospace components and medical instrumentations. And Inconel is also a super alloy of nickel and chrome. So know these as well. Properties we use. High, like, okay, properties. Uh, High strength, durability, high resistance, and excellent mechanical properties. Applications are aerospace, engine components, structural parts, automotive, medical, and high performance industrial applications. Okay, then next, ceramic based 3D printing. The materials we use are alumina, zirconia, kaolin, and silica, etc. Properties are high temperature resistance, excellent electrical insulations, and biocompatibility. Applications are electronics, biomedical, aerospace, and decorative arts. Yeah, and we'll be seeing briefly about these three topics in the upcoming slides.
Yeah, let us now discuss about the filament-based 3D printing methods. And the first method we are going to see about it is stereolithography. And in short form, it is called as SLA. And this SLA is the first 3D printing technology invented in the 1980s. And it is still one of the popular method used in many places. And this SLA 3D printer uses a laser to cure the resin, and this resin then cures to a hardened plastic, and this overall process called photopolymerization. And in this photo, you can see that the projector uh, is the input of the UV lighting, and it comes through a lens, and a mirror uh, uh, guides it through to the platform. And in the platform, the platform moves in X and Y directions, so that the resin is cured by the UV lighting, and the cured resin becomes a solid hardened plastic, and then it is taken out of it. Uh, And here in this image, this is the finished product of the SLA. Uh, uh, the main advantages of SLA is that the finished product have sharp edges, smooth surface finish, and minimal visible layers. Yeah, here are two videos of how the SLA 3D printer works. And the top right corner, you can see that the liquid resin is cured by the UV light, and it keeps on curing, and a layer by layer formation is happening. And here in the bottom, you can see the platform which is moving at the top and the resin at the bottom. And an important fact in SLA 3 printer is that the model you get is like in inverted model. It starts from base and it goes to the top, and the base is attached to the build platform. So you'll get an inverted product. Now let's discuss the advantages, limitations, and material used of SLA 3D printing method. The main advantage is that, as discussed earlier, like it has uh, high resolution. It is capable of producing very fine details and the smooth finish, uh, and material selection. As the resins are used in it, various resins, photopolymer resins, can be used for this. So it can be like rigid resin, or a transparent resin, or a flexible resin. You can choose the resin based on what type of product you want. And next, the speed. The speed of the SLA 3D printer is comparatively like slightly faster than other resin based 3D printers. So the SLA is has more advantages. The limitation is that the material properties. Resin materials can be brittle and may degrade over time when exposed to UV light. As seen before, the resin is cured by UV light. So it may with exposure to UV light and sunlight, it may get brittle over a long period of time, or long run of time. And the post processing, as you can see that post processing, the curing of this post curing of this takes too much of time, cost, and effort. So it is like a limitation of SLA 3D printing. And the build size. As seen in these images, the build size of the 3D print of the model is like very low as we compare to other types of 3D printers. The filament used here are nylon and TPU, that is thermoplastic polyurethane and glass filled nylon. These resins are mainly used for SLA 3D printing methods. Next, next we will see selective laser sintering, or called as SLS. This selective laser sintering is like in which a high power laser is used to sinter small powder particles to form a solid model. Like here in the image, you can see that a powerful laser uh, is like is like diverted from a XY scanning mirror, and it falls on the powder of particles. Then when this laser is it falls on the powders, the powders through chemical reaction it sinters and forms as a solid. And the laser the laser is pointed in a way such that one layer of the model is formed. Then then the layer of powder is recoated, and then this same procedure repeats, forming the model. And the main advantages here is there will be powders in every layers, so that you don't need support structures, because the loosened powders act as a support structure for the model you make. And the main advantage of this is the SLS is ideal for complex geometries, including interior features, undercuts, thin walls, and negative features. This is because the laser is like too minute, and it can have high resolution in uh, printing out the 3D model. The most common material for selective laser sintering is nylon. As you can see, in mostly based on filament based 3D printers, nylon is like uh, used in various types of 3D printers. And this is because nylon is lightweight, strong, and flexible, and as well as stable against impact, chemicals, heat, UV light, water, and dirt. Next, let us see some videos on SLS 3D printer. In the bottom, you can see that the laser is printing fusing the powdered particles, and layer of powder is overlaid above it. Then this process repeats like layer by layer, resulting in formation of a product. And here you can see like a systematic of how the powder is coated upon it. Okay, now let's see the advantages and limitations of SLS 3D printer. Uh, SLS 3D printer can use a variety of powders, including plastics, metals, and ceramics. This 3D printing method not only like involves the plastics, which is of filament based 3D printer, polymer based 3D printer. This method can be used in metals and ceramics also. The powder can be of polymer or a metal or a ceramic, for which the laser can be used to fuse them together. And as I told earlier, no support structures are needed for it, as the loosened powder, which is not like on which on which laser that does not fall, acts as a support structure, which can be later removed during the post processing. Like you can remove the powdered particles after the whole 3D print, and you'll get the desired model. The another advantages of SLS 3D printing is it exhibits a strong mechanical properties, that is high strength and durability. The limitation of SLS 3D printer is that fewer materials can be used for it, as it is in the form of a powder. Only few materials can be used for the making of this method. And the second limitation is because of as we are using the powders, it can result in rough surface and porosity. And third is high shrink rate. As the laser is used, it is like a high energy emitting source. So it can cause the model to shrink. And the fourth point is higher waste than other additive manufacturing. As you have seen, like we are using a large amount of powder, and only a small amount of weight is used to make the model, and the remaining powders are like waste. So in this method, higher waste is generated, and filament used for it. Nylon 12 and nylon 11 are the most common single component powders. Besides nylon, polypropylene, and other popular SLS 3D printing materials. This 3D printing method uses nylon, mostly nylon, and also like polypropylene. Here in this image, you can see that surface is not like smooth as compared to SLA. This SLS does not offer smooth finish to the surface. Now, FDM will be taught by Karthik.
Okay, FDM, fuse deposition modeling. Fuse deposition modeling can be also said as filament fabrication, fuse filament fabrication. It is most widely used type of 3D printing at the consumer level. It is very cheap, so many people can afford it. FDM 3D printers work by extruding thermoplastic filament such as ABS, PLA through a heated nozzle, melting the material and applying the plastic layer by layer to a build platform. Each layer is laid down one at a time until the part is complete. As you see, as you see there, the filament goes through the nozzle. When it comes out of the nozzle, it will come out as a molten state. And when it is laid down on the build platform, it will get sticked on to the build platform layer by layer. And when you see the layer, which is sorry, the build platform, it is already heated up to some temperature so that there will be a better adhesion to the material that has been laid on it. If the build platform is not set up to a temperature, then there will be some kind of um, deformation in the material that has been laid. And FDM 3D printers are well suited for basic proof of concept models as well as quick and low cost prototypes. Can we move on to the next slide? Uh, like the below image, you can see how the FDM 3D printer prints layer by layer. And in the right hand side, there are the components of FDM 3D printer. We have printer bed. As I said before, it should be set up to a temperature for better adhesion. And we have to make sure the print bed is laid flat, uh, like it is not tilted. And we have extruder. Extruder, in extruder, we have printed nozzle. Printed has a cold end and hot end, which helps in melting the material passing through it. And we have feed mechanism. Feed mechanism has motor and gear system, which helps in pushing the material through the nozzle. We have firmware. Firmware converts the 3D model into instruction, which the 3D printer can understand and execute it. We have power supply and display screen. Display screen is used to like intermediate between people who are giving instructions on the 3D printer. We can set temperatures and we can like select a particular coordinate and etc. etc. Can we move on to the next slide? FDM 3D printers are well suited for as I said before, like basic of concept models and prototypes. FDM has the lowest resolution and accuracy when compared to SLA or SLS. It is very cheap, it is very affordable, but the only limitation is that it doesn't give a precise model as compared to SLA or SLS, which gives more precise. SLA gives more precise model than SLS, but also SLS give some smoother surface model. But FDM, if you see FDM like in the right hand side image, you can't. I think you can see there are some layer by layer visible layers of FDM model. Yeah, it shows how inaccurate it is, but it can be used for prototypes and all, because prototypes doesn't need a smooth finish. Okay. Fuse deposition modeling is ideal for basic of okay. Uh, Advantages are cost. It is cost effective. It is very cheap. Anyone can afford it. It is the basic 3D printer, and then material variety. A wide range of thermoplastic materials are available, so any kind of filament can be used. There is no material constraint to only these materials. Ease of use, simple setup and operation, user friendly. Yeah, it is. It can be set up very. The it is not closed as well, so since it is open, we can dismantle the components, and it is easy to set up. Yeah. Limitations: surface finish, limited resolution compared to other technologies, resulting in visible layer lines. Yeah, as I said before, we can see layers visible, unlike SLA or SLS. Material limitations restricted to thermoplastic and some composite materials. Though we have many kind of filament under thermoplastics, but we are only constrained to thermoplastics. We can't use any other apart from thermoplastics. Mechanical strength. Parts may have anisotropic mechanical properties due to layer by layer constructions. Yeah, the mechanical properties are not the same in any direction. So also this is a limitation. Filament material used are PLA, ABS, PETG, polylactic acid, acrylonitrile butadiene styrene, and polyethylene terephthalate glycol. Here are some did you know facts. There's nothing to explain. Can take a look for 1 minute. Okay, like I will tell the Iron Man suit and Star Wars suit. If you have noticed clearly, you can't see any difference like the real one. It is made using 3D printer, and also NASA has given is developing a 3D printer that can print pizzas for the astronauts using the powdered ingredients. Please do scan this QR code to attempt a quiz, uh, which barely takes 20 seconds or 30 seconds. The questions are based on what you have discussed till now. Once done, please react.
Yeah, has everyone joined the quiz? Can I start? Yeah, congrats to Pradeep, Bajpai, and Jashwant, who got 3 out of 5, and they did the quiz well. Yeah, and let's continue with the session. Do you have any doubts about the quiz? Like, do you have doubts in any of the questions? Okay, let's continue with the session. Now we'll discuss about metal 3D printing. Yeah, powder bed fusion is like an important part of metal 3D printing, and it is like an industrial level 3D printer, which is like of big size and used in many industries. And the powder bed fusion, known by many names, powder bed melting is currently the most common type of metal 3D printing. These machines distribute a fine layer of powder over a build plate and selectively melt a cross section of the part into the powder layer. This works like mostly like that of SLS, like the same method of sintering the powder through a laser, but here the powder is a metal powder. There are two distinct types of powder bed melting techniques. One is selective laser melting and electron beam melting. Here you can see that the build plate will be in this level, and one coat of powder will be applied, and the laser system uh, will sinter the will melt the metal particles and make them fuse and form one layer of a model, and then the build will lower and another layer of powder will be coated, and the same process repeats and to form a model. Later, these loose powders will be removed and you'll get the desired model what we need. Yeah, now let's discuss about the selective laser melting. Selective laser melting is the same as selective laser sintering. The sintering word we use for polymer particles and the melting for metal particles. There, two polymer particles will fuse. Here, two metal particles will fuse. The majority of powder fusion metals are selective laser melting machines. As I said earlier, most of the powder bed fusion machines are selective laser melting, uh, which works on the same principle as SLS. SLM machines are high powered lasers to fuse metal layers into parts. After a print, an operator moves the part from the powder bed, cuts the part away from the build blade, and process the part. As I said earlier, after the model is made, the post process include the removal of the powders and sintering of the model to make it more precise and the exact model. SLM printed parts are great for precise geometrically complex parts that would not be otherwise machinable. As I said earlier, this laser help us to print these our desired parts very easily, and the other powders help us support structures. So this method helps us to uh, print more geometrically complex parts than other 3D printing techniques. SLM is used to manufacture complex shaped metal parts such as aerospace, automotive, and medical implants. This is because the aerospace and medical implants industry requires like more precise equipments, because aerospace there should not be any flaw, and so as in medical implants the print should be like precise so that it serves its best purpose. Now let's see about electron beam melting. Uh, Previous in selective laser melting, a laser is used to fuse the particles together and to create that energy. But here, instead of the laser, an electron beam is used for the melting of and fusing of the particles. This electron beam acts as an energy source for it. The electron beam melting is a 3D printing technique that uses electron beam instead of the laser beam for fusing the metal powder in high vacuum environment. As I told you earlier, in the previous method, you don't need like any other you don't need any other support systems. Only you need a build platform, the powders, and the laser system. But here, but here you should require a vacuum chamber. For that, you need like more components and more energy to do that. And these machines have almost all the same constraints, costs, and issues as SLM machines, but are used more heavily in aerospace and medical applications than anywhere else. This method is used only in aerospace and medical applications. Yeah, now let's see the difference between SLM and EBM, that is selective laser melting and electron beam melting. Electron beam melting is capable of printing much faster than SLM when compared to a single beam SLM machine. This is due to the wider beam generated by an electron beam. The width of the electron beam is too large as compared to that of a laser. The laser, the, the width of the laser is like limited up to some nanometers, while this EBM is like much larger than that. So the print speed is high and the print is made much faster. But the limitation is that as the width is large, the the resolution does not meet the standards that of SLM, because in SLM, as there's a thin laser, we can print any model with high resolution. But in EBM, as the thickness is big, you can't print that precise as compared to that of SLM. And EBM requires a vacuum environment. This limits the size of parts that can be built and adds additional complexity to the machine. As I told earlier, EBM needs a vacuum chamber, which increases the size of the machine and also uh, adds complexity to the machine. EBM has a smaller range of possible materials to make use of as compared to SLM. SLM, many materials can be used to make a model using SLM, but it is some materials are limited to EBM because of the electron beam. Now let's see the applications. The main application for the FDM, powder bed fusion, is in medical technology. For example, in for jaw reconstruction, that is, if one side of the jaw is broken, you need a 3D model to attach there. For that, the medical technology department requires powder bed fusion. Here, this model is made use of powder bed fusion. The entire jawbone is printed out of titanium and some other alloys and is implanted into the patient. This process is like very successful right now and has started to happen everywhere. And next, knee replacement. A custom knee joint is created from biocompatible material from each patient for each patient by making use of CT scan data. So, like most people have some knee joint issues, right? So it can be like replaced by a biocompatible material model which is made using powder bed fusion. And next, it is used in automotive industry. Tire molds, seat belt bracket, brake caliper can be used using this method. And in aerospace engineering, rocket engine combustion chamber and the injector head, the most important parts of the aerospace, like aircraft, is made using this. Now, Kati will teach about directed energy deposition.
Third, energy deposition, BED. The process is like the focused energy source, such as laser or electrobeam, is used in DED to deposit material onto a substrate or previously deposited layers, layer by layer. The specialty about this technology is that, like before, we have seen 3D printers where the 3D material, sorry, the filament has been laid down onto the print head, sorry, the print bed. But here it will be laid down on another material like metal or ceramic, etc. DED machines typically use a nozzle that is mounted on a multi-axis arm which can move in multiple directions, allowing for variable deposition. Yeah. Directed energy deposition can be used to fabricate parts, which is generally used for repair or to add material to existing components. Yeah, the main use of directed energy deposition is to repair automotive part. Like when there is a damage in an automotive part, this directed energy deposition helps in laying down the same material, same kind of material, and helps in repairing it. Like in this video, you can see how the uh, directed energy deposition works. You can see already there is a metal placed on the print bed, and you can see some electron beam which melts the material and lays down onto the already existing material. Also, this will happen layer by layer, just like other 3D printers. Advantages are versatility, can repair CAD or create new parts directly from CAD models. Material variety, suitable for metals, polymers, and composites. Scalability, can produce large parts efficiently. Limitations are surface finish. The parts may have rough surface finishes compared to other methods. Just like FDM, also here we can see some visible layers onto the end products. Material waste. Excess material can be wasted during the printing process. And post-processing requires additional machine for finishing to achieve final dimensions and surface quality. Okay. Filament material used are titanium, stainless steel, Inconel. Inconel, as I said before, it is a super alloy of nickel and chrome. Binder jetting. Metal binder jetting is a metal 3D printing method where metal powder is deposited in layers and binder material selectively applied to bind the powder particles together. If you see the right hand side image, it is given step by step. First, after transferring the CAD data to the firmware of the 3D printer, the powder has been applied, and then as a third step, selective addition of binder. Binder has been added onto the powder for for jetting of the powder, and the building platform has been lowered a little down so that the next the same steps can be repeated once again. Likewise, these layers uh, when these layers are finished, after we get the final product, we remove the unbound powders, and finally we get the finished element. This process is repeated until the entire part is built. After throughout the part undergoes post-processing such as sintering to achieve final metal destiny, like we see in the image. After repeating the same processes like until the final product is obtained, after that the powder has been like we have some excess powder which hasn't been jetted onto the material. We remove it and we get the final product. Here you can see a video of how the binder jetting process is being done. Unlike there's no nozzle like other 3D printers. Here it is laid on like you see in the video. The- After powder is laid down, the binder has been
Here,
applied.
after the powder is layered down, the first equipment, that is, it spreads the equipment. It spreads the binder material on the desired shape on the first layer, and next, light is used to cure that binder material, and then another layer of powder is placed on that. This binder material acts as an binding agent and joins these two layers. This process repeats, and once after all layers, uh, the total product is post processed and will get the final product.
Yeah, the advantages are its speed, fast printing speeds suitable for large parts or high volume productions. Material variety can print with a wide variety of materials, including metal, ceramics, and sands, like we seen before. DED also has the same advantage. Low cost, generally more cost effective than other metal 3D printing methods. Limitations are mechanical properties such as parts can have lower mechanical strength compared to parts produced by SLS or SLM. Surface finish, it has a rough surface like FDM or DED compared to like other 3D printing methods. Material infiltration, depending on the material, parts may require infiltration to improve strength and durability. Filament material used here are sand, metal powders, ceramics.
Yeah, next we'll see about bound powder extrusion. This is also another type of metal 3D printing technology. Earlier, we have seen the 3D printing technology is based on metal powders. Here, the metal powder is not used. Instead, the metal powders are like bound and it is used in the form of a filament. The metal powder is like fused with some other polymers uh, for the depending on the properties it need. And this filament is extruded through through a nozzle, and it prints the same as that of FDM printer, what we had seen earlier. There, polymer filament is used, but here a mixture of metal and a polymer is used to print. And then later, the final material will have both metal and polymer. But we need only metal to achieve the final metal density, right? So after this will be cured, or like it will be like heated or sintered so that the polymer melts and only the metal remains after it. Like unlike most every other major 3D printing process, BP machines do not use loose metal powder. Instead, the powder is bound together in waxy polymers. The BP filament is extruded out of a nozzle in a manner very similar to standard FDM or triple F 3D printing, which yields yielding a green part that contains metal powder evenly distributed in waxy polymer. After printing, BPE has two post-processing steps, as I said earlier. First, the polymer is mostly dissolved in a wash machine. There will be polymers present in the filament of the material, right? And it will be removed by washing the model in a solution. Next, the washed part is sintered in an oven. Similar to binder jetting. As similar to binder jetting, the final model will be like sintered in an oven so that the polymer materials are like sintered out and only the metal remains. During the sintering process, the part shrinks to account for the open space opened up by the dissolved binder, yielding a fully metallic part. For earlier, like there will be some polymer materials in here, and all, and in the previous part, like in binder jetting, there will be like binding materials, right? But after once the sintering process is over, these binding particles and the polymer particles will be removed, and we will get like full density metallic part. And here you can see like a model that is taken right away from the BME printer, and this is the final product after the two post-processing methods. First, see, this is an support structure which will be removed, but you can see some green color waxy polymer thing on the top, and you can see some irregularities. But once it is washed and sintered, you will get a final metal model, which is the desired model we want. Next, there is and another greatest advantage of this is earlier in powder bed fusion, we'll use metal powders, which is not safer for the scientists or anyone who use it, because you need special safety measures for the loose powder machines. But here, as it is made into a filament, we don't need some such safety measures. And let's move on to the advantages and limitations. Complex designs. BPA can create very intricate and detailed shapes that are hard to make with other methods. And less waste. As you told earlier, it doesn't loose powder waste will not be generated here, as the whole filament will be used for this, and the small only the small amount of polymer is wasted. It uses materials efficiently, so there's less leftover material after making parts. Mixing materials. BP can combine different materials in one part, making it possible to create parts with unique properties. As I told earlier, when you mix the metal with some waxy polymers, you can mix it based on the properties you want. Like if you want a flexible model, or some flexible model, you can add some flexible polymer, or you want some rigid high density final output, you can use a polymer based on that. So it offers a great advantage for gaining unique properties. The next limitations. Surface quality. BP can sometimes result in rough surfaces or visible layer lines, which may require post-processing for smoothness. As I showed earlier, the BP model has rough surfaces and visible layer lines, but once after the post-processing, you may see some visible layers, but won't be as that of what was it when it was taken out from the printer. Material constraints. Not all materials are suitable for BPE, limiting the range of properties that can be achieved compared to traditional methods. Um, this is because you want the metal to be made into a filament. Only some metals uh, can uses has the property to become like made into a filament. So there are some material constraints in this method. And initial cost. Setting up BP equipment can be expensive, making it more suitable for high value or specialized applications rather than mass production of simple parts. This type of 3D printing is used mainly on industrial purposes, and that too on high value or specialized applications. It is used for some specialized applications rather than some mass production of some industrial parts. The main filament material used are polyamide, polyvinyl alcohol, polylactic acid, and polyethylene glycol. Like these are some uh, waxy polymers which can be mixed with the metal. Now let's see about sheet lamination. Sheet lamination process include ultrasonic additive manufacturing and laminated object manufacturing. Like it is of two types. One is uh, ultrasonic additive manufacturing and laminated object manufacturing. In ultrasonic additive manufacturing, process uses sheets or ribbons of metal which are bound together using ultrasonic welding. Here, two thin metal strips or ribbons will be binded or fused together using the ultrasonic welding. The ultrasonic metal 3D printing utilizes ultrasonic vibrations to layer and bond thin metal sheets or foil together. Ultrasonic vibration removes the oxide layer separating the sheets, allowing them to fuse together. There will be oxide layer on the both sides of the metal foil, which will prevent them from fusing. But using this ultrasonic vibration, we can remove that oxide layer, and which will help the both metal foils to fuse together. The laminated object manufacturing uses a similar layer by layer approach, but uses paper as material and adhesive thread as welding. Like in UAM, that is ultrasonic additive manufacturing. We use metal foils or thin metal sheets, and we join them using welding and ultrasonic vibration. But in the case of laminated object manufacturing, we use two papers instead of the metal strip, and instead of welding, we use adhesives in this method. Now, this is uh, uh, a general look of classification of 3D printing technologies. The binder jetting, powder bed fusion, sheet lamination, direct energy deposition, as we saw earlier, like directly uses the metallic parts, and the vat polymerization material jetting, material extrusion is mainly based on polymers, but can be used for metals also. Some did you know facts? And uh, the researchers from the Tel Aviv University have managed to print a small 3D human heart using the patient's own cells, uh, blood vessels, ventricles, and chambers. Uh, this 3D printing technology is been growing over the years, and will be see and this is called as bio 3D printing technology. We'll see about this later, and and in the right side you are seeing the first 3D printed car, which was printed in just 44 hours and assembled in 2 days. Okay, this is just a thought that you will get during sleep. Okay, now Karthi will teach about ceramics.
Ceramic 3D printer. Like what are used in ceramic 3D printer? The 3D printing ceramic includes aluminum oxide, alumina, zirconium oxide, zirconia, aluminum nitride, silicon carbide, silicon nitride. There are a variety of materials that can be used in ceramic 3D printer. Uh, how are they modified? The process starts by mixing the ceramic powder with a binder to form a thick paste. Unlike DED, that is direct energy deposition, we are mixing the ceramic powder with the binder before the extrusion happens. This paste is then extruded through one of the two types of 3D machines. The first 3D machine has a nozzle in static position and the base moves to form a 3D model. And in other type of 3D machine, we have the nozzle moving, but the base is fixed. The first one looks awkward because the base is moving, but the nozzle is static position, which is not seen in any other 3D printer. Okay, next, why is it used? It is aesthetic, tactility. Tactility means like tactility is a property making it favorite for items meant to be held or touched, like ornaments or something which are not used in any industries, but for touching purposes, for its shiny purpose. Okay. Chemical resistance and biocompatibility, high or low thermal conductivity depending on formulation. Electrical insulator, very hard, high strength to weight ratio. Let's move on to the next slide. Here are some major processes for ceramic 3D printing. First, extrusion. Paste or slurry of clay is pushed through a nozzle and parts are built up layer by layer like on a desktop 3D printer. Yeah. Binder jetting. A binder agent is selectively applied to a bed of ceramic powder one layer at a time. Powder sintering. A high power laser sinters the cross section of each layer onto a bed of ceramic powder. Nanoparticle jetting. Liquid suspensions containing solid ceramic nanoparticles are deposited with inkjets layer by layer. Photopolymerization, DLP. Resin that's filled with ceramic particles is used in a DLP printer that cures each layer into a solid with UV light. Like these are already seen before, but these are the processes that has also been used in ceramic 3D printer. Let's move on to the next slide. Here are some uh, models that has been made by using ceramic 3D printer.
Other types of 3D printing. These 3D printing technologies does not come under what we saw earlier, like uh, uh, metal 3D printing, ceramic 3D printing, or polymer 3D printing. This is like apart from that. For example, bioprinting. As I told earlier in that fact, the bioprinting is an additive manufacturing process that uses bioinks to print living cells, developing structures layer by layer, which imitate the behavior and structures of natural tissues. Bioinks that are used as a material in bioprinting are made of natural or synthetic biomaterials that can be mixed with living cells. Though still in the nascent stages, the progress suggests a future where organ shortages could be a thing of the past. this works like uh, the bio inks or like biocompatible uh, and it is mixed with biocompatible and it is mixed with the cells of the person or the tissues, and it can be used to 3D print an organ or tissue or any bio parts, and this can't be executed on a like a normal atmosphere, but so it is like performed in an secured environment uh, where it has the environment for this process to happen. Next, we move on to multi-jet fusion. Multi-jet fusion is an industrial 3D printing process that produces functional nylon prototypes and end-use production parts in as fast as one day. Final parts exhibit quality surface finishes, fine feature resolution, and more consistent mechanical properties when compared to processes like selective laser sintering. Common application for multi-jet fusion are parts requiring consistent isotropic mechanical properties, functional prototypes, and end-use parts, complex and organic geometries with fine features. Like this is the same as what we saw earlier, like a selective layer melting, but this is the advanced method for that. Here, that is a slow process, but this is an industrial 3D printer, and it can be used to print prototypes or many parts as fast, large amount of parts as fast as one day. And here you can see the comparison. This is the functioning of the multi-jet fusion. It the same process as SLM, but you can see the difference. Within that printing time, see how fast the HP multi-jet fusion prints the product. Okay, now let's move on to polyjet. Polyjet is a revolutionary multi-material jetting photopolymer 3D printing technology that brings your ideas to life with exceptional precision and versatility. From prototyping to production, polyjet 3D printing is an advanced technology that quickly creates precise parts using photopolymers, UV light, and inkjet etch. It achieves accuracy by layering resins to form digital materials and then covered with UV lamps to bond layers. Multiple materials, both rigid and flexible, in a single print. Efficient 3D printing of multiple colors and materials in one model. See, as you see in images, like helmets which is very rigid, and also shoe which is like very flexible of different colors can be used using this polyjet. Earlier we have seen like one single nozzle 3D printer or which can print only of only one color, or you need more time to change the colors, but here it gives us the versatility to have more colors in a single 3D print. Okay, now let's see the current IIT Madras 3D printing club projects. Like this will be helpful for your assignments, and we are doing like 6 projects now. The first is pellet 3D printer. The pellet 3D printer project is like in the finished stage. This 3D printer uses pellets instead of a filament. The filament is very costly, and but the pellets is like a small grain like structures can be used as an alternative for the filament in FDM, fused deposition modeling 3D printers. Pharma 3D printer. Uh, Pharma 3D print in Pharma 3D printer project involves the production of capsules of the desired size. Like some may need like 35 gram, some may need like 65 gram. So this 3D printer prepares the drugs based on the amount like we want. Next, ultrasonic metal 3D printer. As we saw earlier, this ultrasonic metal 3D printer is an advance of what we saw earlier by using less energy. As you see, like the lasers or that nozzles uses like more power, but ultrasonic metal 3D printer uses less power. Next is concrete 3D printer. As from the name, the concrete 3D printer is designed uh, to print a wall or a structure using cement.
cement or concrete. Next, multi-nozzle 3D printer. In all the 3D printers you have seen the 3D printers with a single nostril, right? This multi-nozzle 3D printer has four nozzles, which makes it easier uh, and it can save more time as four nozzles operates at a time. Next, let's see the recap questions. And the first to answer these questions will get some extra assignment marks, and Karthi will look into it. Okay, this is an interactive session, so please turn on your mics for answering. So, first question: what printing technology can be used to 3D print a plastic model with high precision and smooth finish? Yeah, can anyone answer? Okay, the answer is SLA, stereolithography. And second question: name two major printing technologies of powder bed fusion. And the answer is SLM and EBM. Name the 3D printing technology which uses a metal filament. Okay, the answer is bound uh, metal bound extrusion and DED. What 3D printer would you choose for making a simple low cost plastic model? And the answer is FDM. FDM is used to like make simple low cost plastic models. Name one filament material used in FDM.
Polylactic acid.
Yeah, come again.
ABS.
Yeah, correct. Polylactic acid
Yeah,
and
right.
ABS. Yeah. And now scan this QR code and we'll have a quiz. Yeah, this quiz may be tough as compared to the first one. It will have like some questions will have multiple choice which will be indicated. Now try scan this QR code and try the quiz. Yeah, let's start the quiz. Yeah, Kasi Vishwanath, Ananya, and Pratik Bajpai has answered 2 out of 4 questions correct. Congrats to them. Okay, now this is an interactive session. You can ask any doubts regarding the slides, or you have any doubts regarding the types of 3D printers, or regarding the quiz questions, anything. Does anyone have questions? Okay, you can ask through the chat box also if you have any questions. Yeah, attendance will be taken. Like, don't worry about it. One minute. Yeah, I have a small doubt in before a session. Altikura, I couldn't able to print smoothly 3D. Okay, what 3D model did you choose to slice in the Alticura?
Sir, I've designed paradoxical gear in Fusion 360, sir. And then I inserted I inserted in Alticura, and it is getting like uh, some type of gear type of structure is forming on each axis of it.
Okay, you made a single gear, but it's giving like a gear. It's printing a gear on every axis.
Yes, sir. Yes, sir. It is printing like I did not add many models, but it is printing like a gear type of thing on the axis of it. Like extra part is printing on it. Even though it is a single body, like with components, it is showing different components in it.
Okay, the single body is like divided into many components and showing in it.
Yes, sir. If it is
Okay,
possible, can I share this window so that
okay, like I'll give my like number, phone number, WhatsApp number.
yes,
You
sir.
let me this through WhatsApp.
Yeah, okay, sir.
Okay.
Thank you, sir.
Okay, I'll give my phone number in the chat box. You can like copy that, save that, and ask me. Okay, there are no other doubts, right? We'll see about the assignment. Yeah, 1 minute, I'll share my. Yeah, this is the assignment, and this is for 10 marks. Report. Like you want to research and find a new and interesting application of 3D printing technology and write a short report on it. Like you want to research and find 3D printing new 3D printing technology, like which is not said here, but a new application or a new 3D printer which has been started for a you can also give your ideas in it. Like if you want to design, like you have in mind, like uh, on how to design how a 3D printer should be, like what you want to design for some applications, you can also write it in the report. Okay, does anyone have doubt about the assignment? This assignment will also be sent in the Microsoft Teams chat, but make sure to take a screenshot of this.
One correction, the mail ID given in the first, like karthikn18@gmail.com is wrong. Only one K is used.
Okay.
KAARTHIKN18. There's no double K.
Please circulate the Google form so we can submit the assignment in that.
Okay, okay. Google form will also be provided. It will be it will be shared in the Microsoft Teams chat soon. The deadline to submit assignment is like tomorrow night. So please submit the assignment before that, before the deadline. Any other doubts?
This is our third assignment, right?
Yeah. No more doubts, right?
If screenshot is taken, you can leave the meeting. And
Uh,
the assignment will also be given in the WhatsApp group channel if you are there, or else it will be also there in Teams chat.
Microsoft Teams. Yeah. Yeah. Thank you everyone for attending this session.
Thank you, everyone.